All right, so hello and welcome to my project presentation about my project called MIXO. So a bit of background behind this project. So basically the problem I was facing is Spotify has a massive library of music. However, I believe there's still a fair bit of songs which are missing from it and are instead available on other platforms such as YouTube or SoundCloud. And of course, it's a user experience nightmare to have to switch between all these platforms just to play the songs you want in a consistent stream. So the solution I thought of was to create a web app, a web service, which allows users to create playlists and listen back to these playlists, which contain both Spotify and YouTube songs, and maybe more platforms in the future as well. So the objectives I had, so firstly was to create a modern user experience, which looks and feels like other web app streamers, so like Spotify streamers. And I wanted to use user authentication with Spotify, so log in with Spotify, such that I can leverage the security of Spotify's APIs. Next, I wanted to allow users to be able to create, edit, and delete playlists on this web app and store them persistently. I wanted to allow users to be able to search for both Spotify and YouTube songs, all within the app. And of course, I wanted to allow users to be able to play back both Spotify and YouTube songs in a consistent playlist without any interruptions or within this web app. And finally, I wanted to design the service such that it can scale up and down depending on the number of users, and it should be able to support all these users concurrently without any issues. So to accomplish this is the architecture that I used. So firstly, for the front end, I did this in React. So it's a React.js app, which has the advantage of using client-side rendering, meaning that all of the dynamic data displayed on the page is rendered from the client's browser instead of having to pre-render it on the backend server. And so for all of the backend components, they're all containerized in Docker containers, as you can see. So firstly, the Nginx server. So this server is used to serve all the static files from the React.js app and serve them to the client when they access the domain. And also it acts as a reverse proxy to the node server, such that the node server doesn't have to be publicly exposed through its port. So the node server, this is an Express app, and this Express app is used for user authentication. It also uses the Spotify and YouTube APIs such that the keys for these APIs are protected within the server. The user doesn't have access to them. So it uses those APIs, the Spotify API as well for user authentication. And this Express app also interfaces with the underlying database. So the database that I'm using is a MongoDB. So for all of the user information, playlist information, and song metadata, that's all stored in the MongoDB as JSON-like objects. And also I made a Mongo Express component or container, which acts as an admin console such that admins with the password can see into the Mongo database and see what's happening. So as you can see, all of these components are configured into a swarm. So that has the advantage of basically each of these containers can be replicated without any dependency failures, and they can be scaled up and down very quickly. So there is a bit of an issue with having the MongoDB within the Docker swarm. So it's not the most ideal solution, because when you replicate a MongoDB in this kind of swarm configuration, it won't actually pull the data and maintain the data. You'll have data falling out of sync between the MongoDB containers. So yeah, it's not really the most ideal solution to have it in the swarm. Ideally, it would be in its own separated kind of sharded architecture and maintained there. But this was just done for development ease and to make it easy while developing, and it wasn't implemented due to time constraints. So I'd now like to give a bit of a demonstration about how this works in the Google Cloud environment. All right, so here's the Google Cloud setup I have here. You can see I have 3 nodes running. I have 1 manager and 2 worker nodes. And you can see I'm SSH'd into the manager node here. And I can show you, this is what the Docker swarm looks like from the point of view of the manager. You can see it's the leader and it has 2 worker nodes connected. So I can go ahead and start up the service using Docker stack deploy and my Docker compose file. And I'm just going to call the service MIXO. You can see it's created the 4 services. And slowly all of these services will start up and they'll be running. So yeah, you can see here now they're all running consistently, the 4 services, and they've been evenly distributed amongst the 3 nodes there. So yeah, you can see each one of the services has 1 replica running, which is the default for this Docker compose file. So if I go ahead and copy any one of these nodes, public IP addresses, I chose the manager here, I can access the website and then I can log in with Spotify. And then I can create a new playlist. I can access that playlist. I can search for Spotify and YouTube songs. And you can see it's given me a result of both there. And then I can add all these songs into this playlist that I've just created. And in the background of all of this, it's storing it in the MongoDB in the background. So you can see I have the songs all listed there. So one thing you might want to do is if you get a lot of users at once, you might want to scale up the backend, scale up the Node Express server. So to do that, you'd use the service scale, and you can see I've added 2 extra replicas. So now there's 3 replicas of the backend. So yeah, the Node Express server has to do a lot of work. So you might want to scale that up to be able to handle the extra users. So you can see there I have 3 replicas running, and they've been evenly distributed amongst the 3 nodes there. So now there's basically 3 containers running the node server, and you can see the website still working, the data is still there, but it potentially could be able to handle much more traffic. So one thing that might happen if there's a failure, one of the nodes might go down, and in this case, the swarm should be able to correct itself. So you can see W1 I've taken down, and it was running one of the instances of the backend replicas. So Docker Swarm is going to try to reinitialize that service such that there's still 3 replicas running, even though there's a missing node. So you can see now worker 1 has gone down because I suspended it. And yeah, you can see that instance of the backend has been given to worker 2 instead, and the swarm no longer relies on worker 1. It's redistributed it all. So if I refresh the website, you can see it's still working as expected. So one thing that should be noted is if you try to play back Spotify or YouTube songs within a HTTP site, like this one, an insecure site, it won't actually let you do that because the APIs don't allow that. You can only do that on HTTPS. So I've actually deployed this onto my own personal website, which has HTTPS. And if I play a song, I'm able to go back a song. And yeah, so that was a YouTube song. And then it also plays Spotify songs. Yeah, you're able to skip. So yeah, that's my demo, and thank you for watching.